This is the fifth reference guide entry of the fourth unit, and this reference guide will deal with negative exponents. Negative exponents, you'll notice, will be very similar to a lot of the rules that we talked about with respect to rational exponents when we did reference guide entry number 4, but we're just going to be introducing one additional step. We'll talk about what that additional step is here momentarily, but before we do, let's look at some of the lead-in to the reference guide, starting with the first definition. The definition in this reference guide is the word reciprocal, and that's likely a word that you've heard in the past, but to define it, it means two numbers whose product is equal to 1. Now that's the mathematical definition, but in short, or a simpler way of remembering it, is the flipped version of a number. So for example, the reciprocal of 4 is 1/4. And in order to see that, we have to just remember that any counting number is written with a denominator of 1. So while we don't write 4 over 1, that's what that number would be if expressed as a fraction. So when we take its reciprocal, we flip it. So the denominator becomes the numerator, and the numerator becomes the denominator. So 4 over 1 becomes 1 over 4. Additionally, 2 over 3 would flip to become 3 over 2. So that's all that there is to reciprocals. It's just the flipped version of a number. Now, the new material that we're getting into ties into reciprocals. Otherwise, we probably wouldn't have defined it at the start of the reference guide. So this new material ties in with the negative law of exponents, which tells you that if the base is powered by a negative exponent, the base becomes its reciprocal, and the exponents become positive. So if we look at what's in the box here in terms of examples, we can see that come into play. So if you have something like x to the negative m, that's the same as saying 1 over x all to the power of positive m, or 1 to the power of m over x to the power of m, which would be 1 over x to the m. Now sometimes it's a little confusing to see without numbers. When we substitute numbers in, we can see how this kind of plays out. And you'll also see how it's very, very similar to material we looked at in the fourth reference guide. So let's look at a number, or at an example with numbers in it, and see what's happening here. So if we start with a base of 9 over 4, and we have a fractional exponent of negative 3 over 2, the first thing we're going to evaluate is that negative sign. And what that negative sign is telling us to do is flip the base. So the first thing that we do, and you can see this happening here, is 9 over 4 becomes 4 over 9. And you'll notice that the exponent, instead of being negative 3 over 2, now becomes positive 3 over 2. And now we are left with a problem that we looked at on the fourth reference guide. We have a base with a fractional exponent, and we have to solve that. So what we know is that the denominator becomes the index of the radical. So if we have 4 over 9 with an exponent of 3 over 2, that's the same as saying the square root of 4 over the square root of 9, all to the power of 3, because if you remember, the numerator becomes the power to which your base is taken, or your answer is taken. So this gives us the square root of 4, which is 2, over the square root of 9, which is 3, all to the power of 3. Or 2 cubed over 3 cubed, which gives us a final answer of 8. 2 times 2 times 2 is 8, over 27. 3 times 3 times 3 is 27. And that's all that there is. And just through seeing that one example, hopefully you can see how it largely just builds off of what we had been working on in the reference guide prior to this one. Except now, before you start solving your fractional exponent or working with your fractional exponent, you're going to have to take the reciprocal of your base. And these steps are just outlined in the key steps, which is found a little bit further down in the reference guide, which you can see kind of outline what we just did. So step 1, if you're working with a negative exponent, do not change the sign of the base. So if the base starts as negative, it remains negative. You just take its reciprocal. It doesn't become positive or negative. Whatever sign you started with on the base will carry on throughout the question, and we'll do an example with that in a little bit. Step 2, we're going to treat the number as if it's a fraction. So if it's a counting number, like 2, you're going to treat it as 2 over 1. If it is a fraction already, then obviously just continue to treat it as such. Then you flip that fraction, or you flip your base, ensuring that if it was negative to begin with, it remains negative. If it was positive to begin with, it remains positive. Once your base is flipped, you remove the negative sign on the exponent, but it stays the same. So if it's negative 2/3, it just becomes positive 2/3. And then step 4, which is just 5 words, but it will be the bulk of your work. That's where you solve whatever remains. So once you flip your base, you're likely going to be left with something for which you'll have to solve. That's what step 4 is telling you to do. So as we continue to work our way through this reference guide, you can see some examples. And there are 3 that are done for you on the front, and then on the back we'll see 4 that aren't done for you. So 3, exponent negative 2. So again, we're going to take our base and we're going to take its reciprocal. So we're going to treat it as a fraction if it's not written as 1. So counting number like 3, we think of as 3 over 1. We flip that and it becomes 1 over 3. Instead of having an exponent of negative 2, we now have an exponent of positive 2. So that means 1 squared over 3 squared, or 1 over 9. B is where we see a negative base. So we start with negative 3/4 to the power of negative 3. And what's important to note here, and this will come up, is that the negative sign on the base remains. It doesn't disappear. So you flip your base, you flip the numbers. So we start with 3 over 4, we flip it to 4 over 3. But the negative remains the same. So it's negative 3 over 4, and when you flip the base, it's negative 4 over 3. Your exponent becomes positive 3, and then you just solve. Negative 4 cubed is negative 64. 3 cubed is 27. And now when we get a question like C, just want to write this a little bit bigger and kind of sum up everything you need to know about these kind of problems. So this diagram will help us to do that. So the first thing we'll note is that when we get into the problem, the base will become the radicand. The next thing that you'll note is the negative sign, as we've already discussed, tells us to flip the base. The denominator becomes the index of the radical, and that radical will have a radicand of 9 over 25. Hopefully we can see the yellow here. The numerator becomes the power to which you take your final answer. So with that, that one diagram, you can kind of see everything that's happening here or going to happen in this problem. First thing you do is flip the base, that's in green. And you can see if you look now back down to question C, you can see that's the first thing that's been done. Then we're going to work with the denominator of the fractional exponent. It's 2, which means we have to take the square root of 25 and the square root of 9, leaving us with 5 over 3. When that's solved, we take the power. So the numerator of the fractional exponent is the last thing that we work with, which is consistent with what we did in reference guide 4. And when all is said and done, you see that your final answer is 125 over 27. And we're going to do a problem that looks like that in a minute or two on the back of this reference guide. All right, so with that information in mind, we can start to look at some problems on our own. So let's start with A on the back. 7 exponent negative 2. Well, the negative sign tells us to flip our base. So the first thing we're going to do is we're going to flip 7 to 1 over 7, and we change the sign on our exponent. It just goes from negative to positive. So 1 over 7 squared, that gives us 1 squared over 7 squared. 1 squared, of course, is 1. 7 squared, of course, is 49. And that gives us our final answer. That's it, 1 over 49. Now we look at B. Well, the negative exponent tells us to flip our base. So 3 over 10 to the power of positive 3. So the exponent just changes its sign. This is the same as saying 3 cubed over 10 cubed. 3 times 3 times 3 is 27. Now 10 cubed is a bit bigger, but it's easy enough to do in your head. 10 times 10 is 100. 10 times 100 is 1,000. And again, something we've talked about and keeps coming up, if you look at 27 over 1,000 and you have a desire to make that into a decimal because it's easy enough to do, please don't do that. Leave it as a fraction if it's presented to you as a fraction. So those are the two easier ones. Now we get to C and D, which are a little bit more involved. So 16 over 81 to the negative 3 over 4. There's quite a bit going on there. So let's take it one bit at a time. The negative sign tells us to flip our base. So let's start there. 81 over 16 to the positive 3 over 4. Well, we look at our denominator, and our denominator tells us that it's going to be the index of the radical. So we know 81 over 16 will be our radicand. So we're going to take the 4th root of 81 over the 4th root of 16, and the numerator becomes the power. So it's all to the power of 3. So the 4th root of 81, maybe a little hard to do in your head, but you know that it's got to be a pretty small number if it's something that to the power of 4 equals 81. And it is. It's 3. And then the 4th root of 16 is something that has came up a few times. It's 2. So now we have 3 over 2 cubed, and I'm just going to go down here to finish this. That means 3 cubed over 2 cubed. 3 cubed is 27. 2 cubed is 8. So again, leave it as a fraction, and our final answer is 27 over 8. And if you understood reference guide 4, you're probably finding this reference guide pretty easy. There is one new step. That new step is flipping your base before solving your resulting expression. All right, so we'll work on D, and that will be the end of the reference guide. So the negative 1/2, so the negative in front of the exponent tells us to flip our base. So 36 over 25 to the power of positive 1/2. Well, our denominator is 2. That means we're taking the square root of 36 over the square root of 25, all to the power of 1. So I can put my brackets with the power of 1, but I don't have to. Square root of 36 is 6. Square root of 25 is 5. Again, just left as a fraction. And that's all there is to negative exponents. Again, a great deal of emphasis should be placed on reference guide 4. Understanding that reference guide is paramount to understanding this one. But if you understood that material, then hopefully you are okay with the additional step today.